So in the previous class we studied what is flip-flop. So what are the different types of flip-flop? Okay. So flip-flop is one of the sequential circuit. Okay. So the empathy points are, the flip-flops are mainly used to store the previous bit, because sequential circuits are the circuit whose output depends on current input and previous state. Okay. So to store the previous state we need a memory element. So flip-flop and latches are memory elements. Okay. So these two devices are used to store one bit of information. Okay. So it is a memory element. Flip-flops are memory element. And what are the different types of flip-flops available for our friends?
The different types of flip-flops are SR flip-flops, relay flip-flops, T flip-flops and J flip-flops.
Very good. Sit down. So SR flip-flop. So today we are going to see about SR flip-flop. So it has two inputs, S and R. S means set, that is the value of output is 1. Set means 1. R means reset. Reset means 0 value. Okay, so there are two inputs and clock input is needed. Clock input is needed to operate this flip-flop, to activate this flip-flop. So it is called clocked SR flip-flop. Without clock, it is called latches. If there is no clock is present in the circuit, it is a latch. If clock circuit is present, it is called flip-flop. So set and reset. Next, the SR flip-flop can be designed using 2 NOR and 2 NAND gates, and otherwise we can design using 4 NAND gates. So this is the circuit, SR flip-flop circuit. Okay, we are designing this SR flip-flop circuit using 2 NAND and 4 NAND gates. Okay, 4 NAND gates, and this is the circuit using 2 NOR and 2 NAND. Okay, so the true case of SR flip-flop, that is, if S is equal to 0 and R is equal to 0, it will be in previous state. So the previous state is otherwise called hold state. Okay, suppose if the input of S is equal to 0 and the input of R is equal to 1, it will be in reset mode, that is, the output is 0. Okay, and the next input is 1 and 0. It will be in set condition, set state, that is 1. Set means 1. And if we give S is equal to 1 and R is equal to 1, the output is invalid. Sometimes it may be 1, the output of flip-flop may be 1, and sometimes it may be 0. This state is called invalid state. So this is the main truth table of SR flip-flop. So let us see the operation. So this is the characteristic table. Okay. So using this, so we can take this circuit. Okay. So first input is 0 and S is equal to 0 and R is equal to 0. Okay. So if any one of the, consider this, S is equal to 0 and R is equal to 0, and top pulse is applied, that is 1. Okay. So for the output of these two AND gates are 0 and 0. Okay, because if any one of the input is 0, the AND gate will be, the output of the AND gate will be 0. Okay, so let us assume, because here there is a feedback from the output. So now shall we number this gates 1, 2 and 3, 4. Okay, for the third gate, the second output is from Q bar, and for the fourth gate, the second input is from the Q. Okay, so there is a feedback. Okay, so let us assume this will be 0. Okay, so this output is given as the second input. So 0, 0 means what is the output for NOR gate? What is the output for NOR gate? 0, 0 means 1. Okay. Okay. So this output is the second input of 1, and 0, 1 means 0. So it will be the SR flip-flop will be in the previous state. Likewise, we have to give, next we will give 0, 1. So what is the output of first? What is the output of first AND gate? 1 0 0. Okay, and second gate 1. Okay, so let us assume 0. So the output of third gate is 0. This 0 is the, so 0 1 means 0. Okay, so this 0 is applied here, and here also 0. Okay, so if we give 0 1 means the output will be reset. Okay, so this is the characteristic table. So the characteristic table represents the present current output and the next state. Current state, Qn is the current state and Qn plus 1 is the next state. So for 0 0 there are two states, that is Qn. If the Qn is 0, the 0 will be maintained. If Qn is 1, again 1 will be maintained. So it is called hold state. So if we change the inputs 0 1 for two different values 0 and 1, so it will be reset. That is, if we give 0 1, the output will be 0. So for the next input is 1 0. So 1 0 for different current state, that is 0 and 1, it will be 1 and 1. Okay. So for the next output is 1 and 1. Okay, 1 1. That is S is equal to 1, or is equal to 1. So for different current state, that is 0 and 1, it will be in the next state. Okay, so this is the characteristic equation. So using this characteristic equation, we can using this characteristic table, we can minimize this using Karnaugh map, and we can get the characteristic equation. So the characteristic equation is Qn plus 1. What is Qn plus 1? The next state of SR flip-flop, that is equal to S plus R bar Qn. Okay, this is the characteristic equation of SR flip-flop. Okay, operation of SR flip-flop. Can anyone come and summarize today's topic?
Good morning to all. Today's class we see about SR flip-flop. SR flip-flop means set and reset flip-flop. It has two inputs. S means set and R means reset. In SR flip-flop, there are two types of logic gates. One means 2 NOT plus 2 NAND made up of one logic gates. Otherwise, use 4 NAND gates.